Okay. You guys done carbon dating before? Well, not done it, but you've heard of it? Of course. Science 10, right? Yeah, a little bit of physics, sure. It's radioactivity. That's what it is. You see that in science, because physics is science. So what is that in like layman's terms if you're not a science specialist? What does carbon dating do? Who she is? Like who? Your girlfriend? But she ain't dead yet. So she's going to have 100% of the carbon that she has. You have to wait till she dies. Then you can see how long she's been dead. Yeah, that's what we do. Okay? We're carbon-based units. That's what we are. So it does decay over time, and there's actually better ways to do this. Like, this is old school. They do different methods now. Like, I don't know what they are. I can't remember, but I've read them. Okay? There's more accurate ways to do it. But, you know, technology keeps getting better and better, right? As time goes on. Produces the following data. So this is the percent of, and this is C14. Carbon 14 is the stuff that historically they've been testing, right? So, you know, it's a dinosaur. How long ago did it live? Well, let's test how much carbon it's got left, right? We found a man up in the ice, and this is happening more and more. Actually, that's one of the questions in the book. It's kind of interesting. Global warming, stuff's melting. Whereas before it was like 400 feet of ice, now it's slowly deteriorating, and they're finding things in the ice that have been there for like hundreds, maybe thousands of years. It's kind of cool. Like people? Objects? Well,
Really?
yeah. Well, that's, yeah, well, you know, it is confusing. There's always these movies where we find this guy in the ice and we bring him back to life, and he's, you know, like 10,000 years old type thing. Yeah. Okay. So, anyway, 56% left. This is actually what we know. Okay, like someone's measured this. This is carbon 14. Okay, so I'm just going to give you a couple of numbers here. So we can make our own graph and find some answers. So does this kind of make sense? As time goes on, there's less and less carbon 14 left, right? That's how you tell how old it is. Like if it's still alive, well, you're at 100%. I did this out of sequence on purpose to show you that it doesn't really matter. So A. Determine the, not exponential now, logarithmic regression function. Okay, because your calculator does that. You know when you buy your calculator and it says it does 476 different types of calculations? How many have you actually done the whole way through public school, do you think? Like 20 of them? Well, you did multiply, it multiplies, right? You did divide, it divides. I mean, 400, does someone actually list those to see what they do? Even the cheap ones, $9.99 Walmart, does 128 functions. Like what? How many do you need? B. So now we're going to extrapolate, just like we did before. If an object had 85% carbon 14 left, well, this is what people like to know. How old is it, right? Archaeologists. So every time I turn mine on, it resets. But if you've got some lists in there, you probably want to get rid of them. Second function, memory. 4, clear all lists. Enter. Enter. Done. So now when I go into stat, there's nothing there. I got a clean slate. Okay? So put that stuff in. 56, 51, 37, 9, and 70. 47, 68, 55, 56, 82, 14. And is this partly what I'm testing you on when I give this to you in a test? Like your accuracy and how well you can put this in to see if it works? It is, right? So if it doesn't work and you're not getting one of the multiple choice answers there because there's a mistake, you can't really like, Mr. Watson, it ain't working. Okay, I can't help you. You got to make sure you do it properly, okay? So there's my data. What's the logarithmic regression function? Everyone got that? What do I do? Same thing. Stat, calc. Do I want quadratic? No. Cubic? No. Quartic? Linear? No. See above exponent. What is ln again? Natural logarithm. That's what I want. ln regression. Okay, logarithmic regression. Okay? So 9, or hit enter. Same thing as before. I want list 1, comma, list 2. Okay, and if I just want the equation, that's all I do. Enter. ln regression. Okay, logarithmic regression. That's what it is. That's the function. It's in this funny form, a plus b times ln x. Where, what's a and b? It tells you. So that's all you need to write down. Okay, a is 414391. And b is negative 102,728. Well, 0.9. Whoop, 8.9. ln x. Okay, that's it. Yeah, just minus. Same thing. Plus negative means minus. Sure, I don't need to have that there. Okay. But I just want to put it in that form. Now, who's got a really good short-term memory? What kind of a graph is this going to make? Is it going to look like this? Or is it going to look like this? If it's negative, yeah, it's going to be like that. Good. Okay, so that's kind of what we need to kind of see. But to answer B, that's what I got to do. I got to graph this thing. So how do I do that? Well, graph, first of all, you know your window has to get fixed. X, I want to go to, it says 70. Let's go to 100 from 0. And then Y, from 0 to how much? Like 20,000? But maybe I want to go a little bit more because I gotta gonna answer questions, right? Why can't I see anything? I didn't do a scatter plot, right? Second function, scatter plot. Whoop. Plots on, okay, and then everything else looks good. We got list 1, list 2, everything else. Ah, there it is. Okay. Where's my other points here? I see 4. That's... Oh, did I write that down wrong? Yes, I did. I'm sorry. That should be 19,960. So let's fix that. So that didn't look right. There. 1, 2, 3, 4, 5. Does that kind of look like the shape we were expecting? Right? That's what we were expecting, wasn't it? Okay. So that's an appropriate logarithmic regression. Okay, I got the equation for it. Now, how do I find out anything? Because remember, if I trace this, all I get is the points. Okay? I need to know some in between the points. That's called interpolation. Okay, I can kind of, even if you look at this in your graph, you can almost kind of guess. Well, if 70 is 2,900, this is going to be, I don't know, 2,000, 1,500, but that's not close enough. Okay, so how do I get my line again? How do I make a line on here? Stat, calc, okay, go down to ln regression, which is number 9. Second function L1, comma, second function L2, comma, vars, over to y vars, enter, enter, enter. And then there's my line. And it looks pretty good. It's like going right through those points, right? And Brittany and Lewis, you might have to do something different, right? Okay, hang on. So let me just finish this. Now if I hit trace and hit up till I see my function up there, okay, I can scroll all around and find out whatever I'm getting asked. But again, if I want to know exactly, how do I put in 85 here? Is that on X or is that Y? Yeah, X, right? That's the first list here. That was X. That was in L1. I can just put in 85. How long? There's the answer. 1,306 years old. That's how old that thing is. Okay? 85% left, 1,306.